that you find out who's who in the matching pictures, okay? That's a challenge which you got to raise now. Then, Christoph, I'm going to start with you right away here. He's the Vice President for Cloud and AI Engineering at Microsoft and a frequent guest on our Sofa of Wisdom daily so far, right?
Yes, and thank you again for having me.
And actually yearly, I think since 3 years, Christoph, you come to our fair booth and you talk about what we have developed together.
Yep.
So thanks already for that, being very passionate. Then we have Dr. Kalmos. He's the head of research and pre-development at Siemens, also a frequent guest in our panels. And we have a first-timer here on our stage. We're very pleased to have you. Professor Dr. Alin Albu-Schäffer, coming all the way from the DLR, the director of the Institute of Robotics and Mechatronics at the German Aerospace Center and Technical University in Munich. That's what we have in common. Welcome, gentlemen, for being here. Now let's dive into the topic. We've heard physical AI called the next frontier. Let's make this tangible. What does physical AI look like in practice? Can each one of you share a real example? And that's what we're talking. We talked a lot about AI and what it could be, but now we would like real examples and not a vision that something is working now.
You want to start?
I can start, yes. So for me, really, physical AI is at an inflection point today. It's just coming out of the labs into the real world. And what we see here is a system that works well, and we understand that it's going to have a big impact. And the question is not, does it work? But the question is, will it scale in the real world? And I was lucky enough in my career to be in these multiple inflection points in different industries. When I worked at Mercedes-Benz, we were at just the inflection point of getting autonomous driving and automation capability out of the lab into the real world. And the question was which level of autonomy we should release in the market. When I worked at Amazon, we were at the early days of putting large language models in services. And we were trying to figure out which of those actually we can release in the market and how does it scale for hundreds of millions of users. At Google, we take the large language models, make it small language model. We try to figure out how we empower some small devices, edge devices with that. So here today, what we are doing tangibly, you can see it here in the Innovation Hub. We brought what we developed in the lab, which is basically we equip a robot, a standard robot with some intelligence. We call it, well, it's VLA. It's called in the industry VLA, Vision, Language, Action Model. And it's basically a 3 capabilities compressed together in one neural network, where robots can see, can reason, and can act. And the example that we have here is a cobot arm that picks up very flexible material and package them in a case. That's what we have today. It's developed in the lab. We tested it, and now we are trying to test it also in the real world in our factories to see if these can actually scale. That's one tangible example I want to share with you.
Thank you. One from you?
So maybe I'll continue. We started with the first humanoid. Our humanoid, Justin, is now 20 years old. The legged humanoid is maybe 12 years old, and they are stable platforms for developing AI. So what you can do today, we use those humanoids. I'm coming from the German Aerospace Center. So we use those humanoids to help astronauts building up lunar station, maintaining inside the space station several activities. And the point is they are very smart people, but they are not robotic experts. So you would like to have a language model which allows a non-expert to interact with a robot as they would interact with a human. So in natural language, giving instructions which are related to the task and not to a programming language. And this worked very well. We transferred that then to healthcare. So, and this is not a humanoid robot. It's just a wheelchair with a robot arm which can help impaired people to be independent in daily life. So it can help people to grasp a bottle out of the fridge, drink independently, open the door, and move out on the street. And this is human-machine interaction. Again, you would like to have a language model and a natural interaction modality such that a non-expert user can interact with a complex robotic system. And I think now we are going to see this coming more and more in industrial settings. I mean, I have witnessed and maybe shaped to a large extent the cobot technology over 20 years. And I feel like humanoids and foundation models for action, so VLAs, are at the point where cobots have been 10, 15 years ago, right? Where the research works, as Carl said, but now you need to go to scaling.
Well, it's really hard to add anything to the experts already. I mean,
But I'm pretty sure, Christoph, at Microsoft, you have plenty of examples.
Well, I mean, nearly every customer in these days is pretty much thinking about it. It is, to both of your point, it is really getting to the point where not only the autonomy of the systems, but also pretty much bringing them into the physical space is really the place. As for Microsoft ourselves, we are using them as well. We pretty much, our data centers. I always tell others what other companies call factories or warehouses. We have data centers. And in these data centers, pretty much it is a prime example how to think about this human-machine interaction and more autonomy. So it is, because it is physical AI, it is truly everywhere.
Okay, yeah. And there is an iceberg metaphor, impressive demos above the waterline, but enormous unsolved challenges below. What are the hardest problems standing between today's breakthroughs and reliable and scalable? That's the buzzword of this year's fair, I have to say,
Yes.
industrial deployment. Who wants to start?
I can start again. There are a long list of challenges that keep us up at night, but let me give you the top three that I see. The first one is data. Data is very difficult and very expensive. We all remember how large language model got their data. They got it by scraping the internet. There was internet for information, so you can just go and digitalize that. There is no, in physical world, we need motion. We need to digitalize the motion, and there is no such a thing like internet of motion. So we need to create the data. And creating data means having humans standing off in front of the machine doing something called teleoperation, where you literally teach the machine, teach the robot how to do things. Mm-hmm. And you do that over and over again, thousands and thousands of times. Very expensive, very time consuming. And we need to figure out a way to automate this process, make it more efficient. So that's one big headache and one big challenge that we're thinking about. The second one, it's about how we evaluate these models. The models are actually these vision language action models that we talked about. They are coming from everywhere. Some of them coming from Microsoft, some of them coming from research institutes. Some of them are coming from our partners. Some of them we develop in our own labs. How we can evaluate them, how we can actually validate them. We cannot just get the model, fine-tune it, put it in one robot, test in one use case, go to the next robot, test another use case. That doesn't scale. So we need to create that validation process. It's a virtual process that we have to create, and that is one of the big challenges that we need to work on. Mm-hmm. The third one, which is very important for us, is really to work on the integration, because it's just one machine. A robot is just one machine. At the end, it needs to work in a whole factory floor or in a whole plant. And how do you pipe that into the whole automation pipeline is really important. So that's the third challenge. It's a system level challenge that we're thinking about. These are the three things that keeps me up at night.
But there will be solutions for sure.
Working on them.
When we talk about aerospace, Alin, which problems do you have in regards of solving them?
Well, talking generally about physical AI, right? The point of physical is essential here, right? And it's about a very tight integration of the hardware and the software. And I have the impression that many, especially software companies, underestimate the complexity of the hardware part. So that's why I think also Siemens and the cooperation DLR and Siemens brings us in a good position, because Siemens has strong hardware and software skills. And talking about a humanoid, even a human hand and a good robot hand has more actuators than an electric car, right? Looking at a humanoid, you will end up with 30, 50 motors, right? Which you need to control in a synchronized manner. And of course, you need to acquire the data from humans, but also from this hardware. Another big challenge which I see is, as Carl mentioned, there's no ubiquitous data for humanoid robotics yet. And actually, humans don't need hundreds, thousands, millions of examples to learn. So research-wise, one big challenge is how do you integrate existing knowledge with data, right? Data are expensive. The more complex the world in which you act, the more expensive they are. Today, methods are very much focused on data, right? Which, of course, for text and language are available in huge amount in the internet. So I think finding out how to connect knowledge, previous knowledge with data and to accelerate this learning process is another crucial skill. And the last one I addressed before, right? So we see a lot of humanoid robots which are good in whole body motion, locomotion. If we want to be successful in production tasks, you need also dexterity, human hands, right? And human hands are an incredible outcome of nature evolution. If you look at industrial two-jaw grippers, right, it's like you are trying to solve some assembly task with chopsticks. You won't be very efficient, right? So manipulation is just at the beginning. Hands look small, but again, comparing to a car, I think even a hand has more actuators than an electric car. This is just some of the things coming up in the future. So solving manipulation, solving knowledge and data, solving the interaction of software and hardware, I think these are some of the big challenges.
Okay, thanks, Alin. Christoph?
Yes.
Any points from your side in regards of what Microsoft's doing? For sure, you have a lot of data points as well, comparing it to robotic hands.
Now, as we just heard, the hardware is hard. Software is also hard. Software and all of this. So one of the challenges in this space as well is, at the end of the day, you have to think about a robot in two different functions. What does the robot do? And how do I manage 1,000 of those? Because you will have armies of robots. You have to instruct them. It's not like that they're entirely autonomous and just figure out what job to be done. You have to schedule them. You have to find ways. And so in other parts, it is not only about the innovation of the robot itself, but it is how does it fit into your business systems? How does it actually fit into the workflow? How do you schedule and all those things? And so there's a lot of advancements happening in this space. But at the end of the day, it is a new interface that is created because, quite honestly, today you pretty much you have a shift handover and you talk to your employees and you say this is what we need to accomplish. How do you instruct robots? How do you actually tell them that don't do this but do that? So it is a very, very interesting heterogeneous space that we are in, and lots of advancements across everything. But also lots of things that have to be pretty much, you have to rethink those.
Rethink is also because there is a big tension in physical AI between the speed of innovation and safety and security, especially as we talk about factory floors and people working very, very closely with those cobots. So what are we doing here?
I can start again, okay?
I'm gonna go in that
Let's keep
same round, same order all the time.
You always bring the start from the factory side, yes.
Yes. And actually, I spent years in automotive, as I mentioned before. And one thing I learned there is that you never compromise on safety. It's not a function you add on. It's like a basic principle design. You don't release a car with the brakes works 90% of the time. Like that doesn't work. So in the physical world, safety is foundational and fundamental. And when I worked at Google, actually, there was always a way to achieve both, to take care of the safety, but also to run fast. They don't contradict with each other. And the way we did that is to create what we always call a sandbox. And a sandbox, you put all your variables and all the probabilistic approaches inside the box, and then you create the guardrails around it with your deterministic and the guidelines that you want to achieve. In our area of robotics and physical AI, the way that works is you create a couple of layers. You have cognition layer, and cognition layer is where you have your probabilistic models like your VLAs and all of these. and you give the freedom for that to innovate and to be variable and to upgrade all the time. And then you create the safety layer around that. And the safety layer is the one where you implement your guardrails and you put all the limitations that you want to make sure that this will not go in the physical world and create any damage. So that is always important. And then how you achieve speed after that, you achieve speed through testing in the virtual world. And that's why we are working heavily on digital twins, because you can bring that system, test in the digital world first, virtually, and iterate much faster, and then before you actually put it on the factory floor. That's how we do it, and to achieve both.
Yeah.
Great. Jump in, Christoph.
I just wanted to add one aspect to it, if I may. There is actually a new aspect of all of this happening to a point. It's called compliance AI, which is different to responsible AI because it's more about harmful content and all these things. Compliance AI ultimately looks at the operating procedures that you define and makes sure that the models cannot pretty much break out of those guardrails that you just defined. But you, in other words, and it sounds a little bit strange, you have pretty much agents, pretty much supervising agents, because one agent is responsible for, is this compliant, and the other one pretty much does the task. And this two-headed aspect is very important to also have a little bit pretty much sharing of not only trust, but also of responsibility. That is happening as well.
Okay, I'm gonna stay with you. All right. In regards of data, is called the new oil.
Yep.
But it seems like data is more or less more the bottleneck than the real helper. So especially in talking about training data.
So bottleneck or oil, it's more about we are not short on data. We have enough data. That's actually not the concern. Is the data meaningful? Is the data contextualized? Is the data pretty much usable for the scenarios? That's actually a different question. Because you can get data, pretty much no matter where you want to, but really putting it into a context that ultimately says, and is like, I can really not only train on it, but I can run compliance AI, I can do all of those things. That is the hard part. So what is now happening, and there's incredible research happening here, is that you ultimately take patterns. Let's say robots doing a particular task, you take these patterns and then you actually, not so much simulate, but you synthesize these data sets and you say, I now want to have different variances of those things. In order to actually say, I want you to pretty much operate when it is slippery, when it is not slippery, when it is, and all stuff. So it's really about this aspect of knowing pretty much what data sets you work with and then pretty much going there. And that, it's getting better, but it's definitely still a journey. What I always tell customers is pretty much no data, no AI. It's very simple. You cannot AI your way out of this.
And there is vast amounts of data. We just need to use it the right way.
Yeah.
Talking about the journey, that brings me to aerospace again. I mean, all businesses have a fast speed of innovation. But in aerospace, I think you're definitely at the peak of that because you always use the latest technology. Now, when we think 5 years further, where do you see where in your business especially, what does success look like and what must each of your organizations do differently to get there?
So in 5 years from now, maybe also related to what Carl has said before, we will need to deal with the step from the demonstrations we see on the fair to a certified system in the business cases. On the factory floor, I have this experience with the cobots. Developing a prototype which works well on the fair was like 2-3 years. Getting them certified, it was up to 5-6 years sometimes. We licensed the technology for robotic surgery. Mechatronics, one of the biggest medical companies in the world, they needed 9 years, out of that 6 for getting the FDA certification, right? Autonomous driving won the DARPA challenge, I think, Volkswagen 2006. We still do not have fully autonomous cars on the streets because of certification, safety, and those aspects. I think something needs to change, and some aspects have been addressed, right? The guardrails below the AI, I mean, we learned a lot, right? The way you deal with different agents and so on, but we also need to change things on the certification side, right? On the cobots, I felt like we were too conservative, right? I asked maybe developers of trains or cars, do you think today would certify a train which goes with 80 kilometers per hour through the station and you have just a white line to prevent people from entering? So I think we need to accept more risks. And then I see applications, of course. I'm going now for a humanoid to land on the moon. I think we will have robots in industrial settings really in pretty large amount in 5 years from now. Maybe it will take 10 to have the robot at home doing all the household chores. And healthcare probably also this kind, because medical certification is expensive. But let's start with the industrial settings, and I know there are many use cases which are low-hanging fruit, and we can go for them in the next years.
Exciting times ahead, that's for sure. Carl, you want to add on that?
Yeah.
Quickly.
Very quickly, I think the success in this area really will be around the ecosystem. It will be very similar to the mobile industry, where companies who focus on the ecosystem and integration, seamless integration with that ecosystem, are the ones who were successful at the end. And in robotics, it's going to be very, very similar. And I think as we look into this, like I see that the dream is that like a mid-size manufacturer will come one day and look in the digital world and will have the digital twin of their whole factory or their whole plant. They will pick up the right robotic solution for them for automation of certain function. They will commission it in the digital virtual world. They will select it, they will verify it, and then they order it. It comes, it starts acting from day one, maybe week one. But it's up and running, and it collects data, send the data back to the digital world. We fine-tune the model, we send new models. So this is how success will look like in the future, and that's what we all need to build together.
Okay, thank you. And we're looking forward to that joint collaboration. Collaboration brings me to you. Christoph, one last sentence.
With regards to the work? Yeah.
Yes.
So I will make it very short. We humans have something that is called common sense. And common sense, some more do more, some have less. That's a different question. But common sense is a very valuable thing. And you have to bring it into this world. It's a very hard thing. And so all of the efforts that we are driving across the research, the industrial expertise, the software in the backend, there's a lot of effort that really goes into how do we bring pretty much common sensical behavior into the space. And it's interesting, but it will also require lots of collaboration. And we do, and it is getting faster and faster every day.